but it's going to be due on Tuesday. Okay, so 8A says write in scientific notation. Anybody remember how to do this? I think you all had chemistry, so I'm sure you've written lots of things in scientific notation. What do we do?
You go to the front one, and then you do 3.14 times x to the negative fifth.
Actually, it would be positive fifth. So we're going to talk about that in a second because you're moving that decimal left and right. There's all these rules. We're going to talk about a real easy way to remember. But White is exactly right. We need to move that decimal point. Here's the decimal point in the original problem. Scientific notation requires that the decimal, I need a new red marker, the decimal is after just one digit. You only have one digit in front of the decimal point. So 3.14683 times 10 to the 1, 2, 3, 4, 5, fifth power. Well, Mrs. Ward, how do I know if it's positive 5 or negative 5? Well, look at the original number. Is it a big number or a little number? It's big. And when numbers are big, their exponents are positive. If this had been like 0.00 something, then I'm trying to charge my phone, and apparently I get like 0 text messages ever in my life. No one ever contacts me, and all of a sudden I've gotten 2 this morning. Okay, so yeah, so let's try the next one and do the same thing. Now this number is little. Would you agree this is a little number? So when I do my exponent, it's going to be negative, right? This time, I only need to move it one place. So 7.136 times 10 to the, since it's only one place, it would be negative 1.
Do you want us to keep the long trail or just end it at the hook?
Just keep the long trail. All right, now, 9 says, let's do some math with these numbers. So A, the numbers are in scientific notation for you. And we're going to do this in an organized fashion. Okay? So, first thing I want you to notice is everything in this numerator is multiplication. 3.16 times 10 to the 5th times 1.43 times 10 to the negative 8th, right? It's all multiplied. So let's take out our handy calculators and let's go ahead and multiply 3.16 times 1.43. So I'm going to multiply these two numbers together. And I get 4.5188. Now, what do I do with these guys? Now remember, they're being multiplied. So this is going to be 10 to what power? What's my total power in my numerator? Negative 3. So now I have just basically one number on top and one number on the bottom. Now I notice that these exponents are negative, and I don't like that. So I'm going to go ahead and move this one up and this one down. Mrs. Ford, is that legal? Yes, remember this is a multiply. So this is really no different than having a problem like this. Couldn't I move my x's and or my y's in this problem? Yeah, that's all I'm doing. I'm just moving. So that's going to become 10 to the 10th on top, 10 to the 3rd on the bottom. All right, let's take our trusty calculators and do that division. 4.5188 divided by 1.23. And I am going to round this off. Why? Because I got way too many decimal places. So I'm going to say 3.67 just divided. This is a division problem, so I just divided. And now I've got 10 tens on the top and 3 tens on the bottom. So that's going to leave me with 7 tens. Now again, you might have approached that differently. I don't want you doing the whole thing on your calculator, but you may have simplified a little bit differently. Just make sure that's the answer that you come up with. Because you can certainly do things in a different order. All right, one more of those. This one looks easier. It's straight multiplication. So let's go ahead and just multiply these two numbers together. Remember, when two parentheses are next to each other like that, that's times. This is a times. So 3.85 times 4.96. I got 19.096. Now I have 10 tens and I have 13 tens. So altogether I must have 23 tens. Wow, that was easy. Are we done? Is there anything wrong with it?
It's not one that.
Yeah, it's not scientific notation. We did everything right. We haven't made any mistakes. But is this allowed? Can we do that? Nope. So guess what? We're going to have to change this now into proper scientific notation, which means we have to move that one place. So this is going to be 1.9096 times 10 to a power. Now, let's use our common sense here. This number is composed, the original number is composed of two pieces, a number and a power of 10. My answer is composed of two pieces, a number and a power of 10. These two are supposed to be exactly the same, right? They're supposed to match exactly in value. So if I change 19 into 1.9, I am making that number, that part of the number smaller. Agreed? To keep it all balanced, if this part's getting smaller, this part is actually going to have to get bigger. Does that make sense to you? These are supposed to match. So if they're supposed to be the same, and I make half of it smaller, the other half's going to have to get bigger, or else the whole shebang will be smaller. So this is going to go to a 24. That's tricky. That's tricky. And I probably shouldn't have all those decimal places. I would never count you wrong on this, but to be legit, you probably should round that off to 1.91. But I'm not going to be super picky on that. I just want you to know how to use your exponents. All right, let's look at our properties. Which property is illustrated? Here we go. Anybody know? Anybody know what that first property is? Oh, you all know this one. That's distributive. Yep. So you just write distributive, or you can abbreviate it, whatever you want to do, distributive. All right, now B is a little tricky. Look at it carefully. What changed in going from the left side to the right side? What changed? The order of the X and the Y. And when order changes, does anybody know what property that is? Take a wild guess. Name a property you remember. Commutative. So this is the commutative property, and this one is of addition because we're adding the X and the Y. So that's the commutative property. When you see order changing, that's the key, order. then it's commutative. That was B. All right, C. Now look at C carefully and tell me what happened. What? Okay, the order changed. Again, instead of the 6 being in front, the 6 is now at the back. When order changes, what property is it? Commutative. So that one, though, is going to be commutative, and you can abbreviate this, of multiplication. Because it's 6 times and then times 6. So it's the multiplication order it's changing in that one. So A was distributive, we all know that. B and C are both commutative because the order is changing. Now, what's happening in D? What's that property called? It's called the additive identity. The additive identity is what happens when we add 0 to something. When we add 0 to something, don't we get back the identical thing? The additive identity. Let's skip to F real quick. F. That's not the additive identity, that's the multiplicative identity, yeah. So you can just put mult ID. Technically it's multiplicative, but that word takes a week to write, so you can just do mult ID. It's the identity property for multiplication. So what are the identity properties? If you add 0, or if you times by 1, right? Okay. Now back to E. Now look carefully at that one. Did the order of the numbers change? The order of the numbers themselves. 6, 4, 3, 6, 4, 3. That is not commutative. What did change?
The numbers inside.
The way they were grouped. So on the left side, we grouped the second 2, but on the right side, we grouped the first 2. Anybody remember that property? It goes with commutative. Anybody remember the grouping property? How about associative? You guys act like you've never heard these words before. Associative property, have you heard that before?
Yeah.
Of course you have. The associative property. And since we are multiplying, that one would be for multiplication, the associative property for multiplication. We can do the same thing when we add. We can have 6 plus 4 plus 3 equals 6 plus 4 plus 3. That would be the associative property of addition. Our problem, E, is multiplication. All right, anybody have a guess what G is? It's the multiplicative inverse. What happens when I multiply 3 times a third? Don't they cancel? Anytime things cancel, it's an inverse. In this case, we are multiplying and canceling, so it's the multiplicative inverse. Just put mult inverse. The multiplicative inverse. How would I cancel in addition? What would I have to add if I wanted to cancel something out in addition? 6 plus what? Negative 6. The opposite? That's the additive inverse right there. That's the additive inverse. And how about H? What's H? Oh, you know, read it backwards. It's distributive. H is distributive. We talked about that yesterday. We can go both ways. H is another example of a distributive property. All right, so A and H are distributive. B and C are commutative. B for addition, C for multiplication. D and F are identities. D for addition, F for multiplication, E is associative of multiplication, and G is the multiplicative inverse. I think some of you are a little shaky on all that, so in Schoology, I think I'll double check and some extra practice property work along with the answers, so if you wanna just practice that a little bit on your own, you can. Optional. Okay, Louis, you okay? You wanna sit up for me? Are you sick?
No.
Just tired?
No.
You got jet lag?
Huh?
I'm not talking to you, I'm talking to Louis. You okay? Okay, well, sit up. Let's look like this is the most fun class you have all day, okay? All right. P2, here we go. Gotta name all these things. All right, now impress me with your wealth of knowledge. You gotta name all these things. What do we call this thing right here? What is this thing called? Y-axis. What is this thing right here called? X-axis. There we go. I knew you guys could do it. What do we call this point right here? That's called the origin. In the Cartesian coordinate plane, when we go to a different coordinate system, it'll be called something different, but it is certainly called the origin. And these things are all called what? What are these sections called? Quadrants. And they are numbered. This is 1, 2, 3, and 4. And the whole system, whenever you draw that setup, that whole system is called what? Anybody know? It's called the Cartesian coordinate plane. Rene Descartes, one of the great mathematician philosophers. All right, I think I filled everything in, right? Everybody good on that? Vocabulary? Okay, because now we're gonna start doing some math with those concepts. That setup identifies points in terms of an X and a Y. So point A is -1, 3. Point B is 7, 1. And everybody knows how to plot those points, right? -1, 3, I would start at my origin, go left 1, and up 3. Okay, we all know how to do that. So what are we doing in this problem? What do we mean by AB? Does anybody know what that means, what we're talking about? Well, that means the distance from A to B. That's what we're looking for. We want to know how far apart are these points? How far apart are they? We have something called the distance formula, right? Some recognition there, the distance formula, to help us find the distance between 2 points. Does anybody remember the distance formula? This is an important thing. It's like the Pythagorean theorem. It's something we need to remember, the quadratic formula. Those are things we need to remember. Everybody remember it?
Y squared minus y1 over x squared minus x squared.
That is the formula for slope. And that too is a very important concept. The distance formula is this big radical. Now is it ringing any bells? Mr. Meyer and Miss Ludington are going to kill you.
Is it like,
Negative B
Yeah.
plus
It's
or
like-
minus.
That's the quadratic formula.
Oh,
Yeah,
no.
so we need all those things. We need to remember these things, okay? They are important. This is your distance formula. Okay? So basically, what do? I mean, there's a lot of letters up there, a lot of subscripts, a lot of just confusing looking stuff. But basically, what do I need to do?
Plug in.
I need to subtract my x's. That's what this says. This says take your x's and subtract them. Now, the beautiful thing is, it doesn't matter what order you subtract them, because after you subtract them, you're going to square it, and it's all gonna come out positive anyway. So you can subtract them in either order. So I'm looking up here, I can do -1 minus 7. Or I can do 7 minus -1. Whatever flips your switch, it makes no difference, because you're gonna square it. And then what? I need to subtract my y's. So 3 minus 1. No one ever in your life, ever, is gonna say write the distance formula. So you do not need to memorize the formula. You have to memorize what it does. You subtract the x's, square them, subtract the y's, square them, add it together, and then take the square root. So here we go. What is -1 minus 7? -8. But when I square it, I get positive 64. What is 3 minus 1? 2. But when I square it, I get 4. So now I have the square root of 68. Now, we are not going to type that in our calculator and get whatever decimal, 8 point blah, blah, blah. We're not doing that. But if our radical breaks down, we do need to break it down. So let's see if 68 breaks down. Well, 2 times 34. And 34 is 2 times 17. And I'm done, right? But I notice that I have 2 2's. They come out. They come out. Whatever you have 2 of comes out, and whatever you don't have 2 of stays in. Now, every radical, you're not gonna be able to do that with every radical, right? You have to have 2 of something to simplify. If you don't have 2 of something, then you just have to leave it the way it is. Now, having gone through that, I want you all right now to give the second one a try. So I want you to find AB using 2 6 and -5 1. I'd like to hear some answers. Let's just write down what we come up with, what?
E equals 4 radical 5.
4 radical 5 is one of our answers. Okay, anybody get something different? I don't know, that could be right or wrong, so share, did you get something different? Mackenzie? You didn't get something different? What did you get? Okay, well, that's not good. Aubrey, what about you?
I got square root 52.
Square root of 52. What else? Maren?
I got 2 radical
2 radical 5? I love all of these different answers. This gives us something to talk about. Okay, so here we go. What is the rule? What does the formula tell us to do? Subtract our x's. So 2 minus negative 5. Subtract your y's. 6 minus 1. What?
Is there a reason you start with the B? Is
No, you can, it doesn't matter which order you subtract because you're in a square. Think about this for a second. If I do 3 minus 1, I get 2. If I do 1 minus 3, I get negative 2. When I square them, it doesn't matter. So I just do first minus second, but you can do second minus first. It makes no difference at all. All right, what's 2 minus negative 5? Wouldn't that be 7? Squared is 49. And 6 minus 1 is 5. Squared is 25. Ooh, I think the right answer is one we don't even have up there. The right answer is the square root of 74. And that does not reduce because it's 2 times 37, so that's it, square root of 74. Don't lie. Did anybody get square root of 74? A couple of you did? Okay, let's speak up when we're asking for answers. All right, we got one more, and I would love to have a volunteer come to the board and do that last one. Right now, if you don't want to come by yourself, you may certainly bring a friend. You can tag team it. Oh, that's a 2. All right, so who's gonna volunteer to do this? Come on, let's not be chickens, come on. Josh wants to do it, he's back there talking. Get up here, man, come on, come on, come on. Who, you know these kids, who do you want to bring with you, or do you want to do it by yourself?
Mary, can you help me?
Maren will help you, she's awesome. Okay. Here we go. So we're gonna find the distance between these two, and while these guys are bravely tackling this at the board,
This is just like the last one?
it's exactly like the last one. So while they're bravely tackling it, the rest of you guys are going to be working on this, so we can check their answers. So remember our steps. First thing we do is what? Izzy, what do we do first? We subtract our x's,
Yes,
right?
No,
Is that how you put the first one together? Yeah.
Doesn't matter what order. Subtract them in whatever order you want.
Let's call it that. And then
3 squared is
square. Two minus 4.
Once it's done.
Alright, now, negative 5 plus 6, that's 3, so 9.
16.
Remember, you do your subtraction first and then you square. So subtract your numbers
And then,
and
so
square.
now it's 13. And then that can't be reduced.
Right.
All right, these guys, thank
That can't be
you.
reduced, right?
It cannot be
Can't.
reduced, no, 13 is fine. Good job. These guys got the square root of 13. Anybody else getting close? What'd you get?
I got 13 too.
Square root of 13?
Yeah.
Anna, what'd you get?
Square root of 13.
Oh my gosh, this might be right. Let's check it out and see. Let's see. They did -5 minus -8. Now, they did that correctly. Do not mess up on your, like, little kid arithmetic here, guys. -5 minus -8, that becomes a plus, that becomes a 3. And then when you square it, you get a 9. And then they did 2 minus 4, so they got -2. And then when they squared it, they got +4. Remember, when you square anything, it's going to become positive. There should not be negative numbers under here. Okay, these are added together. Square root of 13. Thank you, Mr. Ronderos. Okay, everybody good with that? All right. If you don't already know the distance formula, if you don't know how this works, then you got it, it's time. Get that figured out. That's a guaranteed test question. Okay? Now we're gonna talk about midpoint. We always talk about distance and midpoint together. So think about the coordinate plane that I just had up here. Think about having 2 points in that plane, and then somewhere there's a point right in the middle of those two. That's called the midpoint. Does anybody remember how to find the midpoint?
Can you subtract like x on top, y on bottom or something?
Okay, now that's slope. You guys are so ready for the next section. That is slope, okay? That's slope. Now, I want you to think about this in real life, okay? You take a quiz, you get a 10. We take another quiz, you get an 8. What's in the middle of that? If I have to give you a grade, I'm not gonna give you a 10 and I'm not gonna give you an 8. What am I gonna give you? Now, how did you do that? You added them and divided by 2. The middle value is always the average. Kids, it's easy. So I want the middle x value for my midpoint. The middle x value is going to be -1 plus 6 divided by 2. It's the average. Midpoint is average. Highlight that. Midpoint is average. And then my average y will be 2 plus 4 divided by 2. So now I'll just do the math. So what do I end up with as my final answer? -1 plus 5. -1 plus 6 is 5 divided by 2. And usually we just leave it 5 halves. If you want to write 2.5 or 2.5, that's up to you. There's nothing wrong with improper fractions, 5 halves. And then 2 plus 4 is 6, divided by 2 is 3. There is our midpoint. Right now, find the midpoint in problem B. You are averaging your x's and averaging your y's. Averaging your x's and averaging your y's. Phoebe, what you got?
5/2, comma 5/2.
Whoa, they match? Are we on the same problem?
B?
Yeah, problem 3B.
Yeah.
Tell me how you got 5 over 2. How'd you get 5?
I did -7 plus 2.
Oh, time out. Okay, now it makes sense to me. When we find the average, we have to average our x's. So you added your x and your y and it would be
Yeah.
negative, but yes, you need to average your x's to find the x value. So, let's try that again. So do that again, Edie, and tell me what you come up with. When you average your x's. So -7 plus 0. I got -7/2. Is that what you got this time?
Yes.
And then 2 plus 5. Well, actually, they do both kind of match, only they're supposed to be 7/2. Negative
Yeah.
7/2, positive 7/2. We okay? All right, we're gonna switch gears for just a minute. Talk about circles a little bit. And then, probably, we won't have time today, but next time, we'll apply this to a circle problem. But first, I need to make sure you understand how circles work. Everybody knows what a circle is, and everybody knows that a circle has a center and a radius. Now, what you may not know is that equations that have x squareds plus y squareds, that's a circle equation. You know how y equals mx plus b is a line? Well, x squared plus y squared is always going to be a circle. The center of this circle is at 0, 0, the origin, and the radius of the circle is 4. Now, before I try to explain that to you, I'm going to look at the next one, because I think it's going to be clearer if we look at the next one. This one is also a circle. Now it's got more stuff, but it's an x squared plus a y squared equals to a number. Its center is 2, -3, and its radius is √15. Now, can you look at those two examples and kind of figure out how we can find the center and the radius of a circle? I think it's easiest with this one maybe. See this right here? And then my center came out to be 2, -3. So whatever was hooked to the x, I took the opposite of it. And whatever was hooked to the y, I took the opposite of it. And then how did I get my radius? I square rooted that number. All right, so let's come up here and see if it makes sense with this one. Wait a minute. There's no numbers hooked to the x and y. So, does it make sense that they're zeros? Because I'm supposed to take the opposite of that number, but there's no number. So it's just 0. And then the radius is 4.
Will you want us to just leave them square root if it can't be simplified?
Yes, yes, absolutely. All right, now, quickly, the last thing we're gonna do today is number 5, A and B. We'll start, C is the big problem, we'll start with that next time. Write the equation of the circle given this center and radius. So now you are gonna produce an equation that looks like this. The center is 1, 4. Positive 1, positive 4. So what do you think that equation is going to look like?
X minus 1 squared
X minus 1 squared, Kate says,
plus y minus 4 squared
plus y minus 4 squared, Kate says,
equals 12.
equals, not 12,
32.
36, yes, good. Yep, perfect. That's it, folks. That's it. Beautifully, beautifully done. One more. I'm hitting you with a lot of information. This is all supposed to be a review, so these are things you want to go back and relook at to get yourself up to speed if it's bothering you at all. Okay, center and radius. We're going to write the equation of the circle. Now, somebody besides Kate. Kate's marvelous, but she did the last one. Tilly?
Would it be x plus 3 squared, plus y minus 2? Y minus 2, equals 100.
Looks really good, but one little thing's missing.
Oh, squared.
You gotta have a squared on both of them. Yeah, that's absolutely perfect. Absolutely perfect. Perfect, perfect, perfect. Okay, so we are going to start there next time. And your homework for P1